Hi class. Today we're going to talk about the general equation of a circle as opposed to the standard equation of a circle, and how to start with a general equation and then use that to how to rewrite it so that you can have it as the standard form so that you can see what the center and the radius are. Let's write that down. Let me share my screen. So we're going to talk about the general form of a circle. And just so I'll just write it right here. The general form of a circle is usually written as ax squared plus by squared plus cx plus dy equal to e. Sometimes people like to write the e on the other side. So you can write it like this, or you can write it as ax squared plus by squared plus cx plus dy plus e equal to 0. Either way is fine. That's one thing we'll talk about, and we'll talk about how to convert that, how to convert the general form above to the standard form, which is what we were talking about yesterday. The standard form being the one where you can easily see what the center and radius are. X minus h squared plus y minus k squared equal to r squared. And the process is called completing the square, which sounds kind of funny, right? Because we're talking about circles, not squares, but completing the square means about how we're factoring this. So let's actually kind of start off by working backwards. So I'm going to start off with a nice regular standard form of an equation of a circle. Let's say we have the circle. I should number my pages. Maybe one of these days will be natural. Let's say we have the circle with center 5, -2 and radius of 3. So I'm going to convert that into an equation that's in the general. Well, actually, I'm going to write it in the standard form first. So here's the standard form. Just doing the usual thing. It's going to be x minus 5 squared plus y minus -2 squared equal to 3 squared. Sorry, I kind of blew it there. It's all right. And then simplifying this just a tiny bit, x minus 5 squared plus y plus 2 squared equal to 3 squared is 9. And this is how I would leave it if I was writing it in the standard form. Very obvious that the center is x is 5, y is -2, and the radius is the square root of 9, which is 3. But now I'm going to change it to the general form by multiplying it out and writing it the other way. So to get to the general form, again, knowing these words isn't super duper important, but we do distinguish between general and standard. So these are the names. I'm actually going to multiply this out. So I'm going to do x minus 5 squared is really x minus 5 times x minus 5. And y plus 2 squared is y plus 2 times y plus 2. So then I'm going to FOIL. Now you can do this as quickly or as slowly as you want. There's a pattern when you multiply out something like this squared. You're going to get x times x, which is x squared. I should use the same color here. And then you're going to get a x times -5 and then x times -5. So then you get a minus 5x minus 5x. And then you're going to get a -5 times -5, which is going to be a positive 25. And by the way, the reason we say FOIL, which I never knew until I started teaching math, was it's FOIL, first, outer, inner, last, right? First, outer, inner, last. Anyway, you can do whatever you like as long as everything multiplies everything else. Same deal over here. I'm going to do y times y is y squared. Y times 2 is 2y. 2 times y is 2y. And 2 times 2 is 4, equal to 9. We'll talk about this pattern in just a second here. And then when you simplify this, you get x squared minus 5x minus 5x is minus 10x plus 25. Y squared, 2y plus 2y is 4y plus 4 equal to 9. 25 plus 4 is 29. So x squared minus 10x plus 4y. Sorry, plus I forgot the y squared. I'm just quite squeezed in there. Plus y squared plus 4y plus 29 equal to 9. And then I like to bring my constant over to the other side. So I'm going to write it as, if I subtract 29 from both sides, I'm going to get, let's write this the right way now. And then write the x squared and y squared first. So x squared plus y squared minus 10x plus 4y equal to 9 minus 29 is negative 20. And this is how we would write it in the standard form. Yeah, just so you're aware, whenever you FOIL something out like this, where it's x minus 5 squared or y plus 2 squared, or more generally, it's on the side here, if you have like a plus b squared, you're always going to get a plus b times a plus b, which is going to be a squared plus a times b plus a times b plus b times b, which is b squared. A squared plus ab is 2ab's. So it's going to be a squared plus 2ab plus b squared. So when I was multiplying out like x minus 5 squared, I was really thinking, oh, I'm going to have x squared plus 2 times x times negative 5, which ended up being negative 10x plus 5 squared. You can also write one for a minus b squared, although it's not really necessary. A minus b squared is equal to a squared minus 2ab plus b squared. Anyway, not super necessary to know here, but I felt like it made sense to say it right now because that's what we're talking about. So now the idea is we're going to have some questions where we start with this general form and work backwards to find the standard form so that we can find the center and the radius. So let's, you know what, I didn't do a good job of thinking of examples ahead of time. Oh, well, I'll make some up and maybe they'll turn out to be terrible. Let's start off with the following. Let's try x squared minus, sure, 6x. See, I'm already, let's try that again. So I should really write it in the standard form, the general form, where the x squared and the y squared should be first, which I don't love, but it's the way that it's done. So let's try that one more time. We're gonna have x squared plus y squared. Let's try minus 2x plus 6y equal to, sure, let's try 6. Cool. So this does not look nice at all. So there's a process. And the first part of the process is actually to write it the way I wanted to write it, which was you group the x's together and the y's together. So we're going to rewrite this as x squared minus 2x. And I know what's going to happen here. So I'm going to tell you, you should leave yourself a little blank space. Blank space, not splice. Plus blank. And it is going to be a plus. It's always going to be a plus of blank. And then I've got my y squared plus 6y and plus a blank. Let's use different colors so we can distinguish between what we do here. Equal to 6. And what's going to happen is, since we're going to add something here and here, we're going to add the same thing on the other side, right? Because when you add something to one side of an equation, you have to add it to the other side of the equation. So what are we going to add? Well, this is where we're completing the square. And I'll tell you why the name makes sense after we do it. So what we're going to do is we're going to take the coefficient of x here, happens to be negative 2. Negative 2 divided by 2, always divided by 2, whatever the coefficient is, even if it's not nice. And we're going to square that. That's going to be negative 1 squared, which is going to be positive 1. And that is what we're going to put right there. So we're going to add 1. If we add 1 on the left, we have to add 1 on the right. Okay, same deal over here. We're going to take the coefficient of y, which is positive 6. We're going to divide it by 2, always by 2, and we're going to square it. 6 over 2 is 3. 3 squared is 9. So we're going to throw a 9 up in there. We're not going to throw up. We're going to put a 9 up. Sorry, it sounded gross. I heard it in my head. Like, we're going to throw up? No, that sounds terrible. Okay. So far, we haven't really changed anything. We've written this side. We've just added 1 and 9 and added 1 and 9. So it's still the same equation. Here's where we've actually already completed the square. Here's where we're going to rewrite it. So x squared minus 2x plus 1 can be factored. X squared minus 2x plus 1 is going to be x minus 1 times x minus 1. If you multiply this back out, you would get x squared and then a minus x and a minus x and a minus 1 times minus 1 is plus 1. Same deal here. y squared plus 6y plus 9 is exactly factored as y plus 3 times y plus 3. And 6 plus 1 plus 9 is 16. So I would probably skip this step actually and just rewrite it as x minus 1 squared plus y plus 3 squared equal to 16. This is why it's called completing the square, because you're adding the necessary constants so that you can rewrite the part with the x's or the part with the y's as some quantity squared. We have completed the square. One other thing of note is that after you've completed the square, so when I added the 1 here, the 9 here, this is always going to factor. In fact, I often like to kind of write it like in parentheses here like this. Oops, and I'm missing a plus sign there. That's terrible. There should be a plus sign there. Sorry about that. This completed square is going to factor exactly as x minus whatever, or I should say x plus, yeah, I'm sorry, I squared it got 1. Yeah, I forgot to write the 9 here. Sorry, now I'm like all over the place here. Apologies. So whatever's inside the parentheses here, minus 2 over 2, which is minus 1, that's what you're going to get right there. You're going to get x minus 1 squared. Same deal here. 6 divided by 2 is positive 3. You're going to get y plus 3 squared. Always works that way. Let's do a few more examples, and then we'll do a few more harder examples. Okay, so let's look at something like, sure, I'm just making stuff up. I'll show you the process a couple more times. Let's use the black pen, why not? So x squared plus y squared plus, yeah, we won't make it too terrible. I always go plus, I don't know why, plus 8x plus 10y equal to, I'm trying to think of numbers to make it nice and square. Sure, 28. Why not? Okay. This doesn't have to match that or like the other one that I'm just making things up. I'll try and pick numbers that are different next time so it doesn't seem confusing. So step 1, group the x's together, x squared plus 8x, and leave yourself a little blank. And then same deal, y squared plus 10y, leave yourself a little blank. And you're going to get 8 plus blank plus blank. And now we're going to fill in the blanks. So 8 divided by 2 is 4. 4 squared is 16. So I'm going to do another line here just so you can kind of see my steps here. So we're going to get x squared plus 8x plus 16. Because, right? 8 divided by 2 squared is 16. That's what's going in the blank spot, but I'm just rewriting in the middle line here. Same deal for the next part. Y squared plus 10y plus, let's see, 10 divided by 2 is 5. 5 squared is 25. So that would go right in there. Right in here. I'm going to add the same things on the other side. So I'm going to get 8 plus 16 plus 25. So I haven't changed the equation. I added 16 to both sides. I added 25 to both sides. But now this part is a completed square. This part is a completed square. And this is exactly going to factor as, well, 8 over 2 is positive 4. So it's going to be x plus 4 squared. Plus 10 over 2 is positive 5. Y squared plus 10y plus 25 is going to factor as y plus 5 squared. Or y plus 5 times y plus 5. But I don't really want to write it that way. Oh, I think I forgot to do something on the last problem. I forgot to answer the question that I meant to be asking because on the, sorry, I'll come back to that in a second. I'll finish that actually. I'll come back to this. Sorry. So what I want to say here is we've got equal to 8 plus 16 is 24 plus 25 is 49. So what I want to point out is on the assignment that we're going to be doing in class, I'm going to ask you to find the center and radius for all of these. So here, the center of this circle is definitely -4 comma -5. And the radius of this circle is definitely the square root of 49, which is 7. And just to answer that question back over here as well, here, the center of this circle, sorry, and I'm going back on the notes, terrible, is +1, -3, right? X has to be 1, negative y is -3, so 1 minus 1 is 0, -3 plus 3 is 0. And the radius is the square root of 16, which is 4. I want to point out that this number over here really has nothing to do with the radiuses, right? The radius is not the square root of 6. And over in the second problem, the radius is not the square root of 8. You have to write it in the standard form to be able to look at it and see, oh, there's the center, there's the radius. Let's do one more kind of relatively straightforward one, and then we'll introduce a couple that have some fractions or other weird things going on. This one actually, I'm going to make this one a little bit less nice. It's totally fine. Sorry, let me number my pages. Yeah, page 5. I should just number them ahead of time. That'd be smart. All right, let's try. I'm just going to make something up that's kind of crazy. Let's do x squared plus y squared minus 12x plus, what number haven't I used it? I didn't use 4. That's right, 4y. I think I might have done 4. That's fine. That's fine. Equal to negative 11. Let's see what happens. It's probably going to be gross. It's totally fine. So, usual stuff. I'm going to write it as x squared minus 12x plus a blank, and then y squared plus 4y plus a blank equal to negative 11 plus a blank plus a blank. Now let's just write what we're going to fill in here. So negative 12 divided by 2 squared. That's negative 6 squared, which is 36. So we're going to toss a 36 in there and a 36 over there. And then over here, same deal. 4 divided by 2 is squared is going to be 2 squared, which is 4. I feel like this one throws people off. Sometimes they're like, I have a 4 here and a 4 here. Yeah, it just happens. Add 4 here, add 4 here. Cool. So now this becomes, the numbering here is not important. I just kind of like try to number my steps, but really you can see it's not very consistent. So here we're going to get x minus 6 squared plus y plus 2, right? Because it's a 2 squared there. 4 divided by 2 is positive 2. Squared equal to 36 plus 4 is 40. 40 minus 11 is 29. In case you want to be sure about this, just in case you're not sure, just a quick check before we say what the center is, I'll just point out that x minus 6 squared is x minus 6 times x minus 6. And if we FOIL that out, x times x is x squared, x times negative 6 is minus 6x, minus 6 times x is minus 6x, minus 6 times minus 6 is positive 36. And this is indeed x squared minus 12x plus 36. So that really does factor like this. And similarly, y plus 2 quantity squared is y plus 2 times y plus 2, which is y squared plus 2y plus 2y plus 2 times 2 is 4. And we definitely get y squared plus 4y plus 4. So we did it right. It's good to check though. You don't have to check on your work. I'm saying, I'm showing you it's right. So then to answer the question that I didn't explicitly state, but I'm going to ask you on the assignment, is the center of this circle is definitely the coordinate 6, negative 2. And the radius of this circle is not particularly nice. It's not a nice integer. It's just the square root of that number there. So the radius is the square root of 29. And that's all I can do. There's nothing more I can say about that. I could get out a calculator and say it's approximately equal to something, but I don't want to do that. And I don't want you to do that unless you feel compelled to do it. It is certainly not a requirement at all. Okay. Well, let's look at some examples where things are a little bit dicier. Let's say we want to, let's say numbering. I think we're on page 6 here. Sure, page 6. We'll do like 3 dicey examples and then we'll call it a day. So let's say we have, sure, x squared plus y squared plus, sure. Let's do a 7x minus, sure, a 3y equal to, I'm going to make something up. It's probably going to turn out insanely bad. Well, now that I've said that, I'm going to try to make it really nice. So let me think for a second here. Sure, I'm adding. Gosh, 58 over 4 plus, sure. Let's say it's equal to 3 halves. I think that'll come out okay. If it doesn't, oh well. So, same first steps. I'm going to rewrite it as x squared plus 7x plus blank plus y squared minus 3y plus blank equal to 3 halves plus blank plus blank. All right. Now, things are less nice because the coefficients of x and y are now not even numbers, and so they are not divisible by 2, which is less than ideal, but something you have to deal with sometimes. I'm still going to complete the square in the same way. I'm going to take the coefficient of x or y and divide it by 2. So here I'm going to take 7 divided by 2. I'm going to square it. I really, really don't want to use decimals here. You could use a decimal and do something like 3.5 squared, which is terrible. I don't even want to know what it is in my calculator because it's ugly, but 3.5 squared is 12.25, but that's not super helpful, I find. Instead, I really just want to write it as, well, 7 squared is 49 and 2 squared is 4. So that's what I'm going to add. I'm going to add a 49 over 4 and a 49 over 4. And over here, same deal. I'm going to take -3 divided by 2 and square it. -3 over 2 squared is -3 over 2 times -3 over 2. Or you can do it that way too. If you like, instead of squaring each part, you can think of just as the fraction times the fraction. -3 times -3 is +9. 2 times 2 is 4. I'm adding a 9/4 here and a 9/4 here. All right, so this is where I really think knowing the fact about how this factors is super convenient. So instead of trying to think, right, like before, let's just go back for a second. In the previous example, it's not too impossible to come up with numbers, two numbers that multiply to 36 and add up to -12. It's -6 and -6. Same deal here. Two numbers that multiply to 4 and add to 4 are 2 and 2. Or in the previous one, right? We're trying to factor, can I do this? We're trying to factor x squared plus 8x plus 16. You're looking for numbers that multiply to 16 and add to 8. 4 and 4. So you get x plus 4 times x plus 4. 25 and 10, you want 5 and 5. But here, it's a little bit harder to wrap my brain around the fact that I want something that multiplies the 49 over 4 and adds up to 7. The number is 7 halves and 7 halves. 7 halves times 7 halves is 49 over 4. 7 halves plus 7 halves is 7. It's 14 over 2. That's exactly how we reverse engineered getting this number in the first place. So we know this is going to factor as x plus 7 halves times x plus 7 halves. I'm going to write it as x plus 7 halves squared generally, but I just want to point out, if you multiply this out, x times x is x squared, x times 7 halves is 7 halves x, x times 7 halves is 7 halves x, and 7 halves x plus 7 halves x is 14 halves x, which is 7x. Bam. And then 7 halves times 7 halves gives you 49/4. So it totally works. Same deal over here. You're going to get y minus 3 halves times y minus 3 halves. Y times y is y squared. Minus 3 halves y plus minus 3 halves y is minus 6 halves y, which is minus 3y right there. And -3 halves times -3 halves is positive 9/4. Then over on the right-hand side, I need a common denominator. So 49/4 plus 9/4, those have a common denominator. That's going to be 58/4, right? 49 plus 9, yeah. So I'm going to have 58/4. And then I'm going to multiply 3 halves by 2 over 2 to get 6/4. And hopefully I came up with the right kind of numbers, but it didn't. Sorry, it's also fine. So I'm going to write this as x plus 7 halves squared plus y minus 3 halves quantity squared. 6 plus 58 is 64 divided by 4. Dividing by 4 is never my favorite, but dividing by 2 twice is not terrible. 64 divided by 2 is 32. 32 divided by 2 is 16. So I should rewrite this as x plus 7 halves squared plus y minus 3 halves squared equal to 16. And now I can say that the center of this is -7 halves, comma, positive 3 halves. Or if you prefer, you can use decimals, -3.5, comma, 1.5. And the radius is the square root of 16, which again is 4. Okay, I got 2 more that I'm going to make up. 7. Page 7. I don't know if it's a problem. Let's do another one of those. And I would encourage you to try this one on your own if you have the time. Let's try, let's make it awful. It's not really more awful. I'm just saying words that don't really have any meaning. X squared plus y squared plus, let's write it out of order, plus 5y minus x equal to, I'm just going to make something else that's probably going to turn out to suck. Let's say it's, sure, -2. We'll find out how that goes. All right, so always the same first step. You're grouping the x's, you're grouping the y's. So x squared minus x plus a blank, and the y squared plus 5y plus a blank equal to -2 plus those 2 blanks. Why do you put the x's first? alphabetically we come first. There's no good reason for it really other than X comes before Y in the alphabet. Okay, so what's the coefficient of X here? It's -1. So we're going to take -1, divide it by 2, and square it. -1/2 times -1/2 is 1/4, or -1 times -1 is +1, or -1 squared is +1, and 2 squared is 4. So we're going to add in a 1/4 there, and 1/4 there. And similarly here, 5 divided by 2 squared is going to be 5 squared is 25, 2 squared is 4. So that's what we're going to add in here, add it over here as well. Okay, so now for the factoring. So once again, I don't really think about what I'm doing here. I'm just saying, well, I know it's going to be X plus whatever that number is right there inside the being squared part. So X plus -1/2, or easily written as X minus 1/2 squared. You should check, multiply this out, FOIL it out, write it as X minus 1/2 times X minus 1/2, and see if you actually get that. You should. And then same deal over here. I like parentheses too, but you don't need these parentheses. I just kind of like them to see the other. Oh yeah, this is my completed square here. This is my completed square here. Plus, this is going to end up being, well, it's going to be Y plus whatever number is right there, which is 5/2 quantity squared. Equal to, okay, so I'm going to get a common denominator, or I'm going to add these together. That's 1 plus 25 is 26/4. And -2, I should multiply by 4, -2 over 1. I should multiply by 4/4 and get -8/4. Okay. So all that's really left is simplifying the right-hand side. I don't really want to write the same lines a bunch of times. So let's just write over here on the side, -8/4 plus 26/4. 26 minus 8 is 18. 18 divided by 4 is 9 divided by 2. So close to being a nice perfect square number, but it's not. So I'm going to write this as X minus 1. Ooh, 1/2. Ooh, that's not the prettiest I've ever written it. Let's try that again. Let's say X minus 1/2 squared plus Y plus 5/2 squared equals 9/2. So then our center is positive 1/2, negative 5/2. And our radius is the square root of 9/2, which really does not simplify very nicely. If you really wanted to, you could square root both parts. You could write it as the square root of 9 over the square root of 2, and then the square root of 9 is 3 over the square root of 2. That's not really any better, though. It's not rationalized. So I would encourage you just to leave it like this, even if you see something that's square. And if it was the square root of 9/4, then you should simplify it to 3/2. Or the square root of 9/25, you should square it to 3/5. So if you see that the top and bottom are both nice square numbers, you can definitely simplify that and just take the square root of each part. One more example where we have something a little extra going on. Is this 8? Yes. So let's say we have something like, okay, sure, how terrible do I want to make it? Not that terrible, but I'm going to make it terrible anyway. Let's say I have 5x squared plus 5y squared. I'll add the rest of it. Sure, minus 20x plus 15y equal to, do I want to multiply that? Sure, why not? Equal to 100. So, fun fact, for an equation to be a circle, like for this equation to actually be representing what a circle is, you have to have a positive x squared and a positive y squared, and they have to have the same coefficient. So you have to have a 5x squared plus 5y squared, or a 1x squared plus a 1y squared, or whatever, but they cannot be different. If you have like a 4x squared plus a 3y squared, you actually have an oval, not a circle. So if you have x squared plus y squared, you have something ovalish. And if the coefficients of x squared and y squared happen to be the same, then you actually get a circle. So here, even if the numbers aren't nice, the first step is to divide by the coefficient of x squared and y squared. It's just the easiest thing to do. So we're going to divide both sides by 5. So we're going to get, so 5 divided by 5 is 1. So I'm going to get 1x squared plus 1y squared. 20 divided by 5 is 4. So negative 20 divided by 5 is negative 4x. I should have also rearranged things, but I didn't. 15 divided by 5 is 3y. I should say 15 divided by 5 is 3. 15y divided by 5 is 3y. And 100 divided by 5 is 20. And now we can do about this kind of the usual way. Group things together, x squared minus 4x plus blank plus y squared plus 3y plus blank equals 20 plus blank plus blank. And then usual thing. -4 divided by 2 squared is -2 squared is +4. So -4 there, add a 4 there. 3 divided by 2 squared is 9/4. So I'm going to add 9/4 there. And 9/4. Okay. Common denominator can be a little bit gross, but such is life. All right. So this is one completed square. This is another completed square. So here I'm going to get x minus 2 squared. Here I'm going to get y plus 3/2 squared. And over here, I need a common denominator of 4. Now, I think it's actually going to be hard to do what I really would do, which is I would be like, oh, 20 plus 4 is 24. And then multiply that by 4/4, which is 24 times 4 is. Here's what I should do instead. 20 times 4/4 is easy. 20/1 times 4/4 is going to be 80/4. Right? I'm just multiplying that by 4/4. And 4/1 times 4/4. 4 times 4 is 16. 4 times 1 is 4. And the 9/4 already is 9/4. That was way easier than doing 24 times 4/4, in my opinion. So now, same deal on the right. 16 plus 9 is 25. We've seen that a number of times. And 25 plus 80 is 105. So I can write this as x minus 2 squared plus y plus 3/2 squared equals 105 divided by 4. My center. Again, I'm looking for the values of x and y that if I plug them in, I would get 0 for all this and 0 for all this. If x is 2, 2 minus 2 is 0. So my x coordinate is 2. If y were to be -3/2, then -3/2 plus 3/2 is 0. My radius, again, is not particularly nice. When I say not nice, I mean it's not an integer. Square root of 105/4 is a perfectly nice number. It's as good as any other number. So we get the square root of 105/4. If the denominator happens to be a square number, it often is something we do to simplify it. You could totally write this as the square root of 105 over the square root of 4, which is really the square root of 105/2. You do not need to do this. I would leave it like this. If you really, really wanted to, you should simplify it. You can simplify it like that. All right, that is all I've got. We talked about completing the square and starting with the general form of the equation of a circle and rewriting it in the standard form in the equation of a circle, which is much easier to discern the center and radius of. So let me say that one more time. This is the general form, the circle in green. General form, not our favorite. It doesn't really tell us a whole lot. It's kind of like lines. The general form of a line, like 5x plus 3y equals 2, doesn't tell you a whole lot. It's not easy to see what the slope or the y-intercept is. Whereas the standard form of a line, or the slope, which is also called the slope-intercept form, y equals mx plus b, tells you a lot about the line. The same thing is true here. The standard form of a circle tells us a lot about the properties of the circle. It makes it really straightforward to see, oh, the center is 2 -3/2, and the radius is the square root of that number. So that's the whole story. I'll see you all tomorrow, or today if you're watching it today. Bye.